In this short little video, I'm going to show you how to do an independent t-test or a z-test for two different data sets that are unrelated but we want to compare. So I am on section 8.1 homework. This can vary with the z-test or a t-test. This video will work for both, but I'm going to show you basically how to walk through it. First off, basically a sociologist claims that children spent more time watching TV in 1981 than today. So a study was conducted in 81, and recently they did the same study. They put the information down here into this chart. You're going to assume the population standard deviation is 0.7 for 1981 and 0.7 for today, and we have an alpha level of 0.5. So since they're telling us the standard deviation for the population, this tells us a z-test, z as in zebra. If they didn't tell us the population standard deviation, we would go with a t-test, t as in tiger. So really it's no different when we do this, except it's just the only difference is which button I am clicking and one or two things I would do differently in terms of entering information. So we are going to identify our claim. The claim is children spent more time watching in TV than 1981 than today, because that was spent more time in 81 than today. So this makes this a one-tailed test because the word more than shows up. So children spent more time watching TV in 81 than today is our claim. So the less than or equal to would be our HO. And since the claim just says more than, that's going to go under our HA. So our HA in this particular one is going to be the claim. Now, critical value, 1.645. Well, we know the population standard deviation, and we know our alpha is 0.05, and we're at one tail. So we have one tail, 0.05. I come all the way down to the bottom, and I'm using the 1.645 at the bottom. This is because I know the population standard deviation. So the rejection region is going to end up being if z is greater than 1.645 is our rejection region, because we reject it if it's greater than the critical value. That's why we're using a positive there. So now how do we get the 1.16? Now right here, there's a little piece of information. It says click to copy to table. I'm going to open it up in StatCrunch. I'm going to resize it a little bit just so I have it easier to work with to show you the menu. I'm going to come to stat, and in this case I'm going to use z statistics because I know the population standard deviation. If I didn't know the population standard deviation, I would just turn in t statistics and do the same thing. So I'm going to go z statistics to sample, and in this particular case I have the data. If I already knew the mean and I already knew the standard deviation, then I would just choose with summary. But I don't have the mean, I don't have the I have the standard deviation of the population, but I don't have the mean, so I'm going to just click with data. So now I have to select my two columns. My column number 1 is going to be 1981. My column number 2 is going to be recently. Now here it says standard deviation is optional. I happen to know the standard deviation in this problem because it told it to me. It said in the problem the standard deviation for 1981 is 0.0 or 0.7, and for today it's 0.7. So I happen to know it, so I am going to type it in. Sometimes you don't know it, so you just leave it blank. We are assuming here that we are our HA, let me go back over here, our HA said greater than, so we're going to switch it to this symbol, and that implies that this would be the less than or equal to part. I got everything set up. I'm going to hit compute. I get my information, and out comes my information. So now, how do I get the z value? The z value right here. Find the standardized z statistics. I have z is 1.16. How did I get that? It's right there. There is my z statistic of 1.16. So now I have to compare that to my critical value from up above. In this particular case, if z is greater than 1.645, I end up rejecting it. It's less than, so I do not reject it. Here's a way you can double check it. We have an alpha of 0.05. So there's a 5. If it falls in the top 5%, I reject. Well, if I look at my p-value is 12. So there's a chance I could be between my p-value and my rejection value, my alpha. So since there's a chance I could be between those two, I would be failing to reject. So you can double check your information there. So now that's basically how you run a two sample independent Z or t-test. Independent means they're not related. We're just comparing one to the other and we're seeing if there's a difference. You come to stat, you choose Z or T, depending on if you know the population standard deviation, and then you choose to sample with data or summary, depending on if you already have everything summarized or with the data. So I go to Z, to sample with data or summary, or I go to T, to sample with data or summary. I'm going to wrap this video up with just showing you what I would do if I actually had the summary. So I go to ZStat, to sample with summary. Here, I would literally just type in the mean is like 30.8, the standard deviation is 3.5, the sample size here is, let's say, 15 people. This mean is 33.6. It's got a standard deviation of 2.2. So I would just type in the numbers myself instead of using a column of data to figure that out. So once I did that, I would hit compute and I would still use all the same information. There's my Z statistics, so on and so forth. So I would use the same general approach. I would just type the numbers in instead of having it figure it out for me. So hopefully this short little video just walked you through how to do a 2-sample independent test using StatCrunch.